Moving to the next topic, that is torque in an electric dipole in a uniform electric field. Uniform electric field can be represented by using the parallel lines. Now, here is the dipole minus q plus q, which is aligned with an angle, that is, let's say this is aligned with angle theta. So the angle between the electric dipole moment, which is from minus q to plus q, and the electric field is theta. Now the force experienced by this minus q will be in this direction, which is against the direction of electric field, and the direction of the force on this plus q will be in the direction of the electric field, that is QE. And we can say that this F and this F are having same magnitude, but they are in opposite direction, which will act as a couple of force, which will give rise to the torque. And here this F, let's say this is F1 and this is F2, so this F1 plus F2 will be equal to 0 because they are equal and opposite. It means there is no translatory force experienced by this dipole, electric dipole. It will experience only torque, that is the rotatory effect. So if this Q is acting here and this Q is acting here, तो ये इधर से इसको push कर रहा है, ये इधर से कर रहा है, so it will definitely give it a turning effect. Now this torque is given by F cross the perpendicular distance from the line of action. Now this F is either of the force, that is QE. Now the perpendicular distance is this, and if this is 2a, this is theta, so definitely it is 2a sine theta. So this is 2a sine theta. Now here Q into 2a is nothing but the dipole moment. So this is P, then E sine theta, which can be written as P cross E. So this is the expression for the torque experienced by the electric dipole placed in a uniform electric field. Now the question is, when this torque will be minimum? If theta is equals to 0 degree, so obviously torque is going to be 0. If theta is equal to 90 degree, in that case this torque will be the maximum, which is equals to PE. If again theta is equals to 180 degree, again it is going to be minimum. So it means at 180 degree and 0 degree it will be stable. There will be no rotation experienced by this torque, whereas it will experience a maximum torque at theta equals to 90 degree. What is the SI unit of this torque? It can be Newton meter, and in terms of P and E also you can find it out, which will be the same. For example, for P, which is Q into distance, Q means coulomb, distance is meter, and for electric field this is Newton per coulomb. So again it is going to be Newton meter. So the SI unit of the torque is Newton meter.